Hi everyone, Paul Rosselli here. Yes, we've got a quiz coming up, quiz on labs 5 and 6. Please review the lab book, your assignments, and you should be all set. However, today I'm going to give you an overview and a review of some of the material that will be on the quiz. So here we go. In lab 5, we talked about electricity and the power grid. And I asked you to get something called a kilowatt and stick it into a wall outlet and then put a device in there. If you've got one device that's taking up about 0 point something amps and you've got a 15 amp circuit, how many of those devices can you plug into that same circuit without tripping that 15 amp circuit? All right, next one. You hook up 4 1.5 volt batteries, 4 of them. In parallel. That means you connect all the positives together, connect all the negatives together, and you get the multimeter and you check the very end of the positive and negative, how many volts are coming out of those 4 1.5 volt batteries into the multimeter. Should be able to figure that out. Remember, this is parallel. There's a difference between parallel and in a series. Parallel, all the batteries don't add up to each other. And so if you got 4 1.5 or 2 volt batteries all hooked up in parallel, the end result is about 1.5 volts depending on the charge of the batteries. Also, batteries in parallel always last longer because when one dies, well, they got a backup. They got the next one and the one behind that and the one behind that. Batteries in a series pretty much add up. So if you got 1.5 and you got another one that's 1.5 and you got 2 or 3 more and you add all those up, the accumulative voltage of batteries in the series is you add up all the batteries individually and you get a voltage at the end. If they're rated at 1.5, they might not exactly be 1.5. As we discovered in class, they might be 1.47. Doesn't matter. But in a series, you add them up. And if you've got 4 of them, what's the voltage that should be out of those 4 batteries? Gauge. We talked about gauge. Matter of fact, you did a little experiment getting a bunch of little wires that had different lengths, different gauges, and different materials. I think we only had 1 copper wire, unfortunately. However, that was enough. 1 copper wire, as opposed to nickel silver, gave you some really good data. So, what is a good definition of the word gauge? Look it up on the internet, in your lab book. You should know what that word means. One of the other things we did in class was to get the kilowatt meter and stick it in a wall outlet. The very first thing was the volt button. You press the volt button, and anywhere in the United States, I shouldn't say anywhere, but mostly everywhere in the United States, it's a standard voltage that comes out of a residential electrical wall outlet. What is that standard voltage? You should be able to find that out online or in your lab book, or if you were in class or you participated in class virtually, you should know what that number is. For the most part, they're all rated at a certain voltage. What is that number? Now, a few days ago, we did an experiment using this hydrogen fuel car that had a hydrogen fuel cell in it. It's an electrolysis cell, so it made the stuff and then took the stuff back and produced electricity. Pretty cool, huh? The hydrogen fuel cell used distilled water. Why did we use distilled water? After we put the distilled water through the hydrogen fuel cell, what was produced? What came out of that hydrogen fuel cell? So during that experiment, we took water, a very pure water, H2O. Now, one of the sets of data that you collected was when this thing produced those 2 gases, which one was produced more and in what ratio? So you should be able to do that from your notes. You should be able to do that from your records. You should also be able to do that just from looking at the chemical formula for water. Now, when you did electrolysis with that hydrogen fuel cell, you produced 2 gases. Two gases. Which ones did you produce? And of those 2, which one is an explosive gas? I mean, if you had a little bit and you lit a match to it, poof! When you took the multimeter and put it right up against your set of wires, you were measuring resistance. From your data, can you make a general statement about resistance in regards to the nickel-silver wire as opposed to the copper wire? Can you also make a general statement about the resistance from longer pieces of wire and shorter pieces of wire? What about gauge? Those are the three things you need to know for this quiz. What is the difference between resistance of copper wire and nickel-silver? Again, same length of wire, putting in the same voltage, and I think the multimeter put out 1 volt. So given that 1 volt, what was the resistance? Can you make a general statement of those 3 bits of information? Now earlier you took an electric bill, whether it was mine or one of yours, and you calculated the price per kilowatt hour. So after an hour, we looked at the kilowatt device, and the appliance that we plugged into it measured just under a kilowatt for that hour. Now, if the price of electricity is 10, 12, 13, whatever it is, cents per kilowatt hour, and I run a machine for, let's say, 12 hours or 24 hours or any length of time, can I calculate the cost of running that device for that amount of time? That's what you should know. Okay, that's it. Review all of your assignments. Review the labs in the lab book if you can. Look at your notes. Look at the stuff that you handed in, and you should do fine. Any questions, give me a call or send me an email. Good luck.